Okay, here's part 2 of test 2 review, starting with number 10. So this is again division and multiplication. So what we need to do is factor, flip where there's the division. So we'll move this down and this up. So let's factor everything. Easy trinomial. Multiply to give you negative 72 and add to give you negative 1. It's going to be x minus 9, x plus 8. This denominator is a difference of squares, so x plus 9 times x minus 9. Here, the division sign, so we're going to flip that. The new denominator is a difference of squares, x plus 8, x minus 8. The new numerator is an easy trinomial. Factors of 54 that add to give you 15 are 9 and 6, so plus 9 plus 6. And then multiplication here, so leave them where they are. Both easy trinomials, so factors of 42 that add to give you 13 are plus 7 plus 6. And factors of 49 that add to give you 14 are plus 7 plus 7. Okay, so now's the fun part. Let's cancel everything that can be canceled. So the x minus 9s, the x plus 8, the x plus 9, and let's see, x plus 7, one of them. You'll notice that the x plus 6's here are both in the numerator, so they do not cancel. You may leave it x plus 6 times x plus 6 over x minus 8 times x plus 7. Remember, another way you could write that is, since that factor is repeated twice, you would write x plus 6 quantity squared times x minus 8 times x plus 7. Either one of those is acceptable. This is probably the answer that you would see in the back of books. Okay, this is a complex fraction. Remember, first step, rewrite it as a division problem. So this is 5a squared minus 20 over 2a plus 2 divided by 10a minus 20 over 4a. So now it is one fraction divided by one fraction, so what we want to do is factor, flip, and multiply. So take out a GCF of 5, leaves you a squared minus 4, and take out a GCF of 2, leaves you a plus 1. Flip, 4a is a monomial, it doesn't factor. 10a minus 20 has a GCF of 10, leaving you a minus 2. Alright, this one needs to be factored further. It's a difference of squares, so let's rewrite this. A plus 2 times a minus 2. Bring down the rest of the problem. Nothing else needs additional factoring. And now cancel what you can. So the a minus 2's can go. 2 into 4 goes 2 times. Nothing else will cancel, so in the numerator we have left 10a times a plus 2. Oh, in the denominator we have 10 times a plus 1, and we see there is something that'll cancel, the 10's. So our answer is a times a plus 2 over a plus 1. Another complex fraction, similar problem to the one we just did. First, rewrite this as a division problem. Okay, then what we want to do is factor, flip, and multiply everything that can be factored. So the first numerator has a GCF of 6, so take out the 6, leaves you y squared minus 1. Second, the denominator there, take out an 8y GCF, leaves you y plus 1. Flip and multiply. The new denominator has a GCF of 3, and the new numerator has a GCF of 4y. This needs to be factored further, so go ahead and write everything back down, factoring that difference of squares to y plus 1 times y minus 1. Okay, now we need to cancel everything that we can. So one of the y plus 1's can go, the y minus 1 can go. 3 into 6 goes 2 times. The 4 and the 8, 4 into 8 is 2, and then also the 2's are going to cancel again, and these outer y's. What's left in the numerator, you see everything's canceled except this y plus 1. And in the denominator, everything's canceled, which means it just leaves you a 1, and we never leave our answer with a denominator of 1, so the answer is y plus 1. Okay, so now we want to add and subtract fractions. So remember, when you add and subtract fractions, you need a common denominator. Problem number 13 has a common denominator, so we write down the denominator without any changes there, and then we add the numerators. They're not like terms, so they just combine to give you x plus 1. Now you look to see if this can be factored or simplified, and since this is a sum of squares, it does not factor further. This is your final answer. Nothing more you can do to that. Okay, let's look at 14. We do have a common denominator. Write it down. Remember, when you see a subtraction, we're going to change that to addition and change all the signs of the following numerator. And again, the numerator are not like terms, so just bring it down, 3b minus b squared. Unlike the first problem there, number 13, this one can be simplified further. We have a GCF of b in the numerator, leaving you 3 minus b. And in the denominator, that's a difference of squares, b plus 3 times b minus 3. And the 3 minus b minus 3 differ by a negative, so we're going to cancel them and bring out the negative factor. So what's left over is negative b over b plus 3. And remember, you cannot cancel these b's because this factor is b plus 3. Cancel all of the factor or none of the factor. Okay, number 15, a little bit harder this time. It's another addition problem, but you'll notice that we do not have a common denominator. So the first thing you have to do is factor this denominator, and you see that that will indeed be the LCD. So what we want to do is build up these fractions to have the correct denominator and then perform the addition. So the first fraction, if we compare its denominator with the LCD, we're missing the factor of 2, so multiply top and bottom by 2. That means to distribute the 2 in the numerator to get 6m plus 4 over 2 times m plus n. The other denominator, other fraction there is already an LCD, so we can now perform the addition. 6m plus 4 over LCD plus 4 over the LCD. And combine your like terms here, you get 6m plus 8, 4 plus 4, over the LCD. And now we need to simplify that. So let's factor out a 2 from the numerator. Gives you 2 times 3m plus 4 over the LCD, 2 times m plus n. And these outer 2's can now cancel. So your final answer is 3m plus 4 over m plus n. Okay, one more problem on this tape. We need to factor each denominator so we can decide what the LCD is. So factors of negative 28 that add to give you negative 3 are going to be 8 and 5, so no, not 8 and 5. Okay, so we factored each of the denominators, and we see that the LCD is 2 times x minus 7 times x plus 4. Now we need to build up each of these denominators so that they have that LCD. So this first fraction, when you compare this denominator with the LCD, it's missing the factor of 2, so multiply top and bottom by 2, so you get 10 over the LCD. Second fraction, 7 over 2 times x minus 7, when you compare that denominator with the LCD, you're missing the factor of x plus 4, so multiply top and bottom by x plus 4. You require to distribute in the numerator, gives you 7x plus 28 over the LCD. Now let's do the addition. So let's write this as an addition problem. So we get 10 over the LCD plus 7x plus 28 over the LCD. So now when we combine this, combining like terms in the numerator gives you 7x plus 38 when you add 10 plus 28. That's not going to simplify any further, so we want to rewrite this problem writing out the LCD, because we never leave LCD in the final answer. You actually have the factors written out. So that would be the correct answer.